Namaskar, good morning. Today the topic is compiler design and the introduction of phases. Well, first of all, we need to understand what is compiler all about. It is a complex enough program or a system software by which we can convert any high level language source code into machine level language executable code. So if we are talking about compiler, the subject is compiler design. It is working in total 6 phases. So there is a provision of a phase structured compiler. The 6 phases are working independently where each phase has its own meaning. Well, there are several phases. One is lexical analysis, known as a scanner. Another one is syntax analysis, known as parser. Next is semantic analysis, also known as type checker. Then intermediate code generation, then code optimization, and then the final phase that is known as code generation phase. Well, today my topic is to explain you about the first phase of compiler, that is lexical analysis phase. Further, it is known as scanner. Well, have a look at the basic phase structure onto the PPT structure. Let us focus on the PPT. Well, this PPT said the phases consist of the 6 blocks. The source program entered from this point passes through lexical analyzer, which is known as scanner. Then the output of the scannings are directed towards syntax analyzer, known as a parser. Output of syntax analyzers are applied as an input in semantic analyzer. Then after semantic analysis or type checking process, output of type checker is known as intermediate code generation, then code optimization, then code generation. After passing all 6 phases, we get a target program, which is basically assembly level mnemonic code. We'll explain it in the board. Well, compiler is not limited to the basic conversion of program from high level language into machine level language. Apart from it, this is known as the basic structure of compiler, but there is some additional task can be performed by a compiler. So we are observing 2 parallel phases. One is symbol table manager, another one is error handler. Both are connected with each and every phase. Compiler is responsible to find out some errors along with the basic conversion process, and this task is performed by the error handler part. We will explain it in chapter number 4. Well, one more thing, that is a symbol table manager. Basically, it is a simple data structure. We already studied data structures and all characteristics in analysis, design of algorithm and data structure chapter. Let us focus on the first phase of compilation, that is lexical analysis. Coming on the board. Well, what is lexical analysis all about? We have to focus about it. What is lexical analysis? I have some simple questions for you people, like, what do you understand by this character? What about this? What about this? You will reply me the answer. This is alphabet A, this is alphabet B, this is alphabet C. What actually you are doing, you are just scanning, this is A, this is B, this is C, and you are replying me back, A is the first alphabet of English. A can be written as small a. A can be treated as apple. A can be treated as anything, acquiescent, abrasive, whatever. There are so many words which can be directed through that the first letter, capital A. So you are just performing the scanning and providing me the output. This scanning portion is known as lexical analysis, and you are providing output of scannings to me all these output are collectively known as lexeme value. So we are totally focused on the first phase, that is lexical analysis. How lexical analysis is performed and how we can scan a particular value. Well, there are two parameters. In first phase of compilation, there are two parameters. One is regular expression and another one is finite state machine. These two collectively combine with each other and convert it as a result. That result is known as the scanner, also known as lexical analysis part. Well, first let us take a review of finite state machine. What is all about? We have already studied in earlier chapter in 5th semester. Right now we are in 7th semester, so we have to just take a review of it. Finite state machine is a mathematical model which consists of total 5 things, that is Q, sigma, del, Q naught and that is capital F, where Q are collection of states. Each and every machine has several states. Like if we take example of this fan, currently this fan is off. It is a winter season, the fan is off. Well, if fan is off, then what is the task you are performed to make it on? There is a associativity of a switch, and when you press a switch, this fan becomes what? On. But just assume it, if power supply is not given to the fan, whenever you are applying a switch, it will not change its state to the on state. So finally, this is a basic mathematical model. The fan can be switched on after applying an input switch, and fan can be still remain at off position even after applying a switch part. So this finite state machine is basically divided in 5 tuples. First tuple is Q. Q can be treated as Q naught, Q1, Q2, Q3, and there are n number of tuples. These states can be theoretically explained as some machine state. Next is sigma. Sigma is a set of input values. It can be alphabets, it can be numbers, it can be a spatial character, algebraic notation, plus, multiply, symbolic notation, like that, just for a theoretical purpose. The next thing is, that is delta. It is input transition function, can be represented in 3 possible ways. One way is represented by the basic structure that is known as state transition diagram. This is a very basic structure or a model structure by which we can understand the working of the finite state machine model. This del transition can be illustrated by this state transition diagram, or we can simply make a table structure where we simply represent Q0 is giving Q1 as an output after providing the input small a. So this is known as state transition table. And the last way to represent this del is a simple equation known as a transitional equation. Del means input transition function. Q0 is the input state. When Q0 is reading A, it is providing you output state Q1. So this del is known as input transition function, can be illustrated by total 3 parameters. One is a state transition diagram, another one is a state transition table, and the last one is a state transition equation. Next is Q0. Each and every machine consisting of some initial state. Suppose the fan is a machine. The common state where fan is always lies, that is, it is off position. So considering the scenario that the machine is by default existing in off position, so for a common machine, off is treated as the initial state of it. So Q0 is known as default initial state for a theoretical purpose. And the last thing, that is F. F is set of final state. There are n number of possibilities that a machine can perform your task, and all tasks where we take a final output are known as final state. A machine can have 5 final states. A machine can have 1 final state. A machine can have n number of final states. Suppose this fan can provide you fresh air by number of possible ways. 1. It is simply rotating at a speed of 200 rpm. It is simply rotating at a speed of 400 rpm, 600 rpm. There are possible 3 ways just maintained and executed by a simple regulator. There is a regulator in the switchboard जिससे आप क्या कर सकते हैं, इस फैन की स्पीड को कंट्रोल कर सकते हैं. That is a simple machinery. तो ये फैन आपको 2 या 3 तरीकों से हवा प्रदान कर सकता है. तो ये इसकी फाइनल स्टेट कहलाएगी. तो all these things together collectively give a basic idea, basic scenario, basic fundamental logic behind finite state machine. Let us take a brief review of it. A finite state machine consists of 5 elements: Q, sigma, del, Q naught, F. Q is non-empty set of all the states. Sigma is non-empty set of each and every input associated with the machine. Del, our input transition function, can be illustrated by diagram, table or equation. Q naught is the default initial state of machine. F is set of final state and it can be empty at a moment. Well, coming on the next part of finite state machine, that is the classification. We can classify finite state machine in 2 possible ways. A very common way, that is, a finite state machine can be NDFA and a finite state machine can be DFA. NDFA stands for, that is, non-deterministic finite automata, and where DFA stands for deterministic finite automata. Let's take example of this fan again. Suppose one day you are sitting in this lab, you feel tired, you just press this switch to open or to convert this off position fan to the on position. What you have seen, this fan is rotating clockwise direction. आपने एक इनपुट दिया, इस पंखे को चलाने के लिए एक बटन दबाया और ये पंखा क्लॉकवाइज डायरेक्शन में घूमने लगा. आप अगले दिन आए, आपने फिर बटन दबाया, पंखा एंटी क्लॉकवाइज डायरेक्शन में घूमा. आप फिर आए, बटन दबाया, पंखा पेंडुलम की जैसे घूमा. फिर बटन दबाया, पंखा इस तरीके से कोने कोने में जाके घूमा. आप अगले दिन आए, आपने बटन दबाया, पंखा घूमा ही नहीं. What is happening right now? You are just providing one input as a button, and every time you are pressing button, this fan is behaving a different output. This fan is providing some different output. Such machines which carry different output or no output are known as non-deterministic finite state machine. We can illustrate it as a technical definition, that is del Q into sigma tends to 2 की power Q. Del is the input transition, Q is any state, sigma is any input, and if any state reads any input, it can provide you number of possible output state, that is illustrated by my example given earlier. 2 to the power Q, power set of a state, which can include 5, which can include 1 state, which can include number of state. Where on the other side, deterministic machines are those machines which provide only one output state after reading any input. Let's take one example here. By taking a transition table, del A, there is a Q naught. Q naught is reading A and providing you Q0, Q1. Q1 is reading A, providing you nothing. This type of table is known as NDFA table. But if we are constructing a table like this, Q naught is reading A and giving you 1 del, and Q1 is reading A, giving you Q0. So each state gives only one output state after reading any input. Q1 is reading A and giving you one output state, that is Q naught. Let's take Q1 is the final state. Q1 is the final state. This is NDFA table and this is DFA table. Fine. So finite state machine characterized in 2 parts, NFA and DFA. What What is NFA? When any state provide you 2 to the power number of Q output possibility, then it is known as non-deterministic situation of the machine. But if a state give only one output, not only one output, each state of the machine is associated with every input value and it will provide you one output associativity after reading that input, then it is known as deterministic machine. Well, this is for today, that is finite state machine model. We are discussing about the compilation. Let us review the class. Compiler is a source program, a converter. It is a program which converts high-level language into machine-level language and executable language. To perform this task, compiler has to pass with total 6 phases. These 6 phases are lexical analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization, and code generation. Each and every individual phase is connected with 2 parallel phases. One is error handler, another one is symbol table manager. Alright. We are discussing about the first phase, which consists of 2 possible parameters. One is regular expression and second one is finite state machine. Fine. So we just take a basic fundamental logics of finite state machine, as we already learned all these things in earlier chapters in previous semester. Finite state machine, it is 5 tuple structure: Q, sigma, del, Q naught, F. Q is non-empty set of all the state, sigma is non-empty set of input value, del is input transition function, Q naught is default initial state, and F is set of final state. And last but not the least, this FSM is divided into 2 parts, NFA and DFA, and the fundamental difference between both is transition will perform when a state reads an input and provide you 2 to the power Q combination of output. In DFA, transition is performed when a state reads any input and provide you only one possible output value. This is the thing for today. Thank you so much. I am Sumit Vashishtha from Computer Science and Engineering Department, Sagar Institute of Research and Technology, hoping for your best future. Thank you so much.